This sample problem involves looking at the difference between distance and displacement and speed and velocity, and it's similar to the horse problem on your classwork. So it says you have a basketball player that sprints from one end of the gym to the other in 3.5 seconds, and then the player turns back and runs to half court in 2 seconds. The length of a basketball court is approximately 28.65 meters, and I looked that up, so that's actually how far it is. And I want to know what is the average speed and what is the average velocity. So we know there's a difference between these two because speed is a scalar and velocity is a vector. And speed is dependent on distance and velocity is dependent on displacement. So in order to just define the parameters, I always take the problem and I just kind of want to draw out and make a picture for myself so everything is clear to me. So here's my basketball court. There's half court, and I know the length of the basketball court is 28.65 meters. And so that would make the distance between the end and half court half of that, right? Because half court, so that would be 14.325 meters. Right? And I know based on the problem that the person ran to the right all the way, and that took 3.5 seconds, and then turned right back around, and we'll just ignore any time it took to turn there, and did the other half in 2 seconds. So the first question is, what is average speed? So average speed, if you recall, is total distance over total time, right? So the time's easy. It took the player 3.5 seconds to run down and 2.5 seconds back, so we just add them together, and we get 5.5 seconds. Now for distance, remember that distance is the total ground you covered. It's a scalar. The direction does not matter. So it's going to be the 28.65 meters plus the 13.25 meters. So that's the total distance. Add those together, and we get 42.975 meters. So if I just divide the total distance by the total time, I get roughly 7.8 meters per second. So meters divided by seconds. Now, if I want to then answer the question, what is the average velocity, this is going to be just slightly different, right? So we're going to say average velocity, and velocity is dependent on displacement. So that would be the total displacement over total time, which remember that displacement is your change in your position from where you originally started, and it is a vector, it has direction. Time is a scalar, so that's going to stay the same for both of them, 5.5 seconds. But the displacement is going to be from where the player started to where they ended up. So the change in position, or the displacement, sometimes it's written with change in x or change in d, is going to be from here to here, which would be just half of the court, right? So we know it's 14.325 meters in the positive direction. Now we could also treat these as vectors in this case, and we could think of it a different way mathematically, where we say, well, to the right is the positive direction, and to the left is the negative direction. And then if I were to add those together, I would be 28 minus 14.325, and I would get this, right? So that is my change in my position, or my displacement. And so the actual average velocity for that person is going to be 2.6, so a lot slower. 2.6 meters per second. So, and this, this seems like the velocity and speed seem like they would be the same concept, but you can see that they are very different when it comes to physics. So hopefully this will help you solve the problem on the classwork about the horse if you got stuck.